Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to present our research presentation entitled SUAS-based infrared thermography for rapid temperature measurement in buildings and solar photovoltaic panels for thermal distribution analysis. And my name is Ahmad Anas Yusof. I am from the Faculty of Electrical Engineering, University Technical Malaysia, Melaka. So my presentation has 5 subtopics, and for the introduction, basically our research involved the use of infrared thermography. In this case, it is basically a non-contact technique that is used to measure temperature. Okay, so basically, by using this technology, we can evaluate building thermal distribution and other kind of measurement. Okay, and at the same time, we are using drone technology also in this case, so that we can measure the temperature from above. So by looking at this image that we have here, you can see that this is a flight nearby the faculty buildings, and we can identify the temperature differences of the plant, okay, nearby the building, which is around 34.4 degrees Celsius, and the temperature of the road, okay, at near to the building as well, about 43.7 degrees Celsius. So, and basically all of the measurement is conducted at the University Technical Malaysia Melaka. And if you notice in the figure, this is our building here, our faculty, and the next one is the building of the Chancellery buildings. And also we have a small solar panel here, which is our third site for the test. Okay, and basically the utilization of a small unmanned aerial system based infrared thermography is basically led by Robotics and Industrial Automation Research Group within our Faculty of Electrical Engineering. And it is actually part of the initiative in smart energy management and monitoring in our university UTM. And so straightforward for our research, our focus on measurement at that moment is that we are measuring 3 sites. Okay, the first site is known as the Chancellery building. The second site is the lobby, the main lobby of our faculty, and the third site is a small solar panel station, okay, nearby the faculty. And if you can see, is that the rectangular here is our monitoring station. Okay, so basically we fly to these 3 locations, in order to obtain our measurement. Right? And if you look here, this is our this is our setup during the experiment. So we have our drone standby nearby, and we have our remote controller, okay, and also our display here. So basically, through this display, we can identify the temperature difference during the flight or during the measurement. Yeah. And to be exact, we are using a small UAS known as a parrot bebop thermal. Okay, so it's basically weight around 600 grams, and it has a maximum flight time of 25 minutes. And it's basically have operating frequency of 2.4 gigahertz. Usually the maximum operating distance for this type of drones or SUAS is about 2 kilometers. Okay. And going straight away to the results and discussion, you can see here, this is our first building, which is the Faculty of Electrical Engineering. And by looking at the slide here, we can see a pattern of temperature and a pattern of different type of temperature distribution around the buildings, okay, on the buildings. And if you look carefully, we can see that at this the first data here is the temperature measured at the wall, which is about 34.3 degrees Celsius. This is basically against the sun. Okay, because we have a part area which is facing the sun and the other area is against the sun. Okay, and you can notice, you can see that for the balcony here. Okay, so this part of the balcony has a temperature of 37.2 degrees Celsius, while the other exposed balcony is about 53.2 degrees Celsius. So you can see that there's a difference between the shaded area and a non-shaded area. And the temperature difference is about 50 degrees, about 15 degrees Celsius, 15 to 20 degrees Celsius. So, so basically, you know, shading is really provide an influence on the measurement of the temperature from this point of view. Okay, and we can see that from above also at the plant. Okay, kita ada tumbuhan kat bawah ni. So the exposed plant here is about 36.1 degrees Celsius the temperature, and the exposed road here is about 50.6 degrees Celsius. Okay, so so this is basically the measurement that we get, okay, by using this technique. And moving on to the next building, our next building is Chancellery building here. So according to this, you can see again a different type of temperature reading that we have. So we have one temperature reading at the roof here. This is our roof. The second one here is at the wall here. Okay, so this is the wall here, the white wall. And then you have the gray wall. So this is the gray wall here is facing the sun, while the other gray wall here is against the sun. Okay, so it's basically shaded area. Okay, so from here you can notice you know, a temperature difference, a lot of temperature difference that we can have. So again, exposed roof about 57.3 degrees Celsius. So if you look at the exposed white wall, you have about 37.5 degrees Celsius. So this is a white wall. So the color is white, it's different with the gray one. So if you look at the exposed gray wall, the temperature reading at that surface is about 54.4, and this is about 37.5. So there's about around 15 to 17 degrees Celsius of difference. Okay, you can notice. And if you look at the shaded gray wall here, this is shaded gray wall, and so again, between shaded area and exposed area, you also have a good amount of temperature difference here. Okay, so basically, we can see that it is basically influenced whether you have direct direct sun towards the surface or not. Okay, so it's depend on the location also in this case. And here is the other part of the Chancellery building. And then we can see that if we go through this area here, so we have exposed roof of the temperature up to 61.8 degrees Celsius, it's very hot. And you have an exposed white wall at this area is for 38.3 degrees Celsius. And the gray wall is about 58.2 degrees Celsius. So again, this is about 20 degrees Celsius of difference. Okay, based on color, based on color of the wall. Okay. So this is another site, which is our solar panel site, a small solar panel site, which has a different temperature as well. Okay. And if you can see here, okay, of course, but if we look at the image at the roadside here, the temperature is about 43.2 degrees Celsius. Okay, and by looking at the solar panel, you have what we call it, a value ranging from 38.1 degrees Celsius. The other one is actually 40.8. Okay, and we have also around 37.3 degrees Celsius. So it's basically varies on the panels. And if you look also, there is some anomaly here as well. Okay, anomaly of the temperature reading as well on the panel itself. But however, we must be careful also with the reading, because sometimes the reading on the solar panel is influenced by the background of the surrounding. Okay, So since this is from glass, so the background of the surrounding, maybe the sun itself may influence our reading. So when we do measurement on this panel, for example, we have to be careful and we have to double check our reading as well. Okay. And if you look on this exposed plant here, the temperature is around 34.7 degrees Celsius. Okay, so so basically this is the data that we have when we measure our solar panel. Okay, so as a conclusion, basically, when we do this measurement, the rapid measurement in this case, so we can see that from drone's point of view, you know, from a certain height, the temperature distribution of the building are basically affected by, the first one is shading. Okay, so a shaded area versus non-shaded area give a different temperature. It's about 10 degrees Celsius to 15 degrees Celsius. And at the same time, the color of the building itself, whether it's white or gray, also influence the measurement. And of course, the material itself, or the building material itself. So if it is glass, or if it is asphalt, or if it is concrete. So all of these give a different kind of temperature. Okay, and we should know that the heat signatures actually varies greatly due to emissivity. So this is a property well known in infrared thermography. And at the same time, it's good to know the condition of the material and also to know the characteristics of the material, okay, to understand the thermal distribution, okay, of the area itself. Okay, and why is this important? Because if you do analysis in heat transfer, for example, the temperature difference is very important, so that we know what is the rate of heat transfer between the wall or between the surface at that time. Yeah, so that's why by doing so we can basically see that this part here loses heat a lot or getting heat a lot. Okay, from this point of time, for example, or for this point of angle. Okay. So for that, I conclude my presentation, and thank you. Thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.